How do wind turbines generate electricity? That's today's video. Hello, I'm Wayne and welcome to Energy Warden. Also in this video we're going to be discussing the types of wind turbine and how much electricity wind turbines produce. If you're thinking about buying a wind turbine, you need to watch this. Let's get into it, shall we?
Although wind turbines are nothing new, many people are not sure of how to create electricity from wind. The basic principle behind a wind turbine is fairly simple. Instead of using electricity to power a fan to make wind turbines use the wind in order to make electricity. The wind turns propeller-like blades of a turbine around a rotor. This spins a generator which then generates electricity. The process of converting wind to mechanical energy is fairly simple. Wind is energy. Wind itself is a type of solar energy. It is caused by a few different factors: the sun's uneven heating of the atmosphere, irregularities in the surface of the earth, and the rotation of the earth. Most people also recognize that some areas of the world are much windier than others. This is due to environmental features such as water, vegetation, and differences in terrain. For example, wind speeds in the Midwest can be incredibly high as there are few trees and the ground is fairly flat. Wind speeds in forested areas tend to be low. Wind plays a variety of roles, from generating electricity to even leisure activities. Sailing, flying a kite, and generating electricity are just a few examples of the practical uses for natural wind today. When people discuss how to generate electricity from wind, they often use wind energy and wind power to describe that phenomenon, although both terms mean the same thing. This is simply the process that wind is used to generate mechanical power or electricity. The mechanical power can be used for specific tasks, or it can be turned into electricity with the help of a generator. Historically, wind power has been used for specific tasks such as grinding grain. Windmills that are present in some parts of the Midwest and Europe were used historically to take on physically taxing jobs, although there was not a way at the time to store that energy. The process of turning wind energy into electricity requires a wind turbine. The aerodynamic force from rotor blades, which function like an airplane wing, is used to create energy. The air pressure from the wind creates the rotor to spin, and the rotor is connected to a generator. This may be done either directly or through a shaft and a series of gears. This movement is a type of energy which can then be stored and used for other purposes. Types of wind turbines. When considering the types used today, there are two primary categories: horizontal and vertical turbines. 1. Horizontal axis turbines. This type of turbine is the most common today and is what most people picture when they think about a wind turbine. They typically have three blades with a turbine pivoting at the top of a tower. 2. Vertical axis turbines. This is a less well-known type, and it comes in a few different varieties. The Daru model is one example, and its appearance has a somewhat egg-beater style. These turbines are omnidirectional, so they don't have to be adjusted to point into the wind, making them a more versatile type of turbine. Regardless of their type, a turbine can be built on land or offshore, as wind speeds may be significant in bodies of water. It's becoming more common for turbines to be built offshore in recent months. Sizes of wind turbines. Many people want to know how much electricity a wind turbine can generate. The answer depends on the type of turbine as well as its location. However, these are the primary types available today. Utility-scale turbines. These types range in size, but tend to be the ones that most people have seen before. The larger turbines are more cost-effective and often grouped together into a wind plant. This can then be used to provide power to the electrical grid. Offshore wind turbines. These are a large type of turbine and usually taller than the Statue of Liberty. They do not have the same transportation challenges of land-based turbines and can be transported on ships. These turbines have the ability to capture powerful ocean winds and generate a huge amount of electricity. Small single turbines. These turbines are usually below 100 kilowatts and may be used for residential or small commercial applications. A small turbine may be used in a hybrid energy system along with other energy resources. It's also common to see them being used in remote locations where a connection to a utility grid is not available. How much electricity does a wind turbine generate? A typical turbine will start to generate electricity when the wind speed reaches 6 to 9 miles an hour. Any wind less than this won't generate any electricity. However, if the wind is blowing too hard, typically more than 55 miles an hour, the turbine will shut down to prevent damage. Over a year, a functional turbine can generate usable energy over 90% of the time, making it a practical choice for energy use. The amount of electricity that it generates depends largely on wind conditions in the area. For a larger wind turbine that is 2 megawatts, the maximum output in a year is 17,520 megawatt hours. This is actually twice the amount of hours in a year, which is significant. However, a turbine may only produce 7,884, or roughly half of that amount, if the wind isn't blowing hard enough to generate the maximum amount of electricity. This means that the turbine would only have a 45% capacity factor. In most cases, wind farms have capacity factors that are greater than 40%, making them close to the efficiency of coal and natural gas power plants. Wind energy efficiency. Although wind energy is dependent on weather patterns, it's a fairly efficient and effective way of generating electricity. After the turbines are connected, they can either be used to collect energy for storage. However, it's more common for them to be connected to the power grid for immediate use. With a goal of relying less on other types of energy such as coal and natural gas usage, wind energy is anticipated to continue with its steady growth. For further information on wind turbines, please read my factual articles explaining how do wind turbines work without wind, or how do wind turbines work. This one has an infographic showing the parts of a turbine.
Those two articles mentioned at the end of the video, I'll leave a link to in the description below. Please have a read of them, there's loads of information there. And if you liked the video, please give it a thumbs up. And subscribe if you wish. Now, let's watch another of my videos. Choose one of these, I'll see you there. Cheers!